Welcome to our lesson on derivatives of logarithmic functions. So a typical logarithmic function is ln x, okay, ln x. But ln x is a log, okay, ln x is a log, but it's a special kind of log. It's log to the base e, okay, log to the base e. That is what ln is. Okay, so when you are differentiating ln x, all right, the answer that you expect is 1 over x. Okay, this is a fact, it's a law that you need to know to help you in the further studies of logarithmic functions, especially their derivatives. Hence, dy dx, okay, when you are given this function, dy dx is 1 over x. So based on this, we are going to come up with a rule or a formula to help us differentiate all logarithmic functions. So consider y to be equal to ln of f of x, okay, ln of f of x. Then you let u be equal to the inner function, okay, so let u be equal to f of x. If that is the case, then it means that y will now be equal to ln u because f of x has become u. Then we differentiate both u and then y, okay, so that will be du dx. That should be the differential of f of x, and then we have come out with a definition that when you differentiate ln x, the answer should be 1 over x. Therefore, when you differentiate ln u, you should have 1 over u. Okay, so dy du is 1 over u. Then we will apply the chain rule on this to get the dy dx. Right, so using the chain rule, we have dy dx as this, okay, dy du times du dx. Like I always tell you, the first, which is dy, comes first, and then dx ends the chain, okay? All right, so we know what dy du is, that is 1 over u, and then we know what du dx is, that is the f prime of x, or the first differential of the function. Right, so let's substitute, and then this is what we have, okay? But remember, u, we said let u be equal to f of x, so let's clean it up. All right, so this is what we have. So what this means is that when you are given a natural log, okay, and you are differentiating, a natural log is the same as the ln, okay, and we are differentiating it, then differentiate the function, okay, and then divide by the function itself, okay. So let's come up with a general rule, okay, a general rule. Right, so okay, let me conclude on this, then you come up with the general rule. So when you are given ln f of x, what you are doing is that you would touch the f of x, you would differentiate it, and then you divide by f of x itself, and you are done. It's that simple, okay? So now in general, when you are given any natural log, any ln, okay, you differentiate what is inside, and when we are to differentiate this, we will have what? A, right? Because ax and plus b, when you differentiate, you have a. Then you divide by the same function that you differentiated, and that is ax plus b, and you are done. So now let's practice some examples and see how this actually works. Our first example, we have y is equal to ln 12x, and our job is to find dy dx, okay? So like we said, we shall differentiate the 12x, and then we will divide by the 12x. Okay, so that's the plan. Let's do that. We differentiate 12x, and we have 12. We divide by 12x. This should give us 1 over x. Another example. We have y equals ln of 2x plus 3. Okay, 2x plus 3. So this is the same plan. We are going to differentiate 2x plus 3, which will give us 2. Then we divide by the 2x plus 3. Okay, so let's do that. Divide the x equals, we differentiate this, we get 2, and then we divide by 2x plus 3. So that's the idea. Differentiate it and divide by the same thing. Okay. Well, we have this one. What do? The same idea. We are going to differentiate this and then we would divide by the same thing. Okay, so let's do that. When we differentiate this, remember the 2 come and multiply here. Okay, so you have 2 into bracket 3 plus 1 all raised to the power 1. Okay, but power 1 is the same thing. So then you go inside bracket and then you differentiate, and that is 3. And this is what we call the chain rule of differentiation. All right, I have a video on the chain rule of differentiation, so if you need more clarification, I suggest you go and watch that video. Right, then we will divide it by the same thing. Okay, so we divide it by the same thing, then we clean it up. Okay, so 3 times 2 will give us 6, so we have 6 of this. Now remember, this and that can cancel out. This is double, this is 1. So when you cancel out, then we have 6 over 3x plus 1. Okay, this is an error. This is an error because we have cancelled. So this shouldn't be there. The power 2 shouldn't be there. Right, now this one looks a bit scary, but it is nothing. It is nothing. The idea still holds. We will differentiate this and then we divide by the same thing. Okay, so now let's differentiate it. All right, now when we differentiate this, we are going to get 2x, and the differential of ln x is 1 over x. Okay, so let's see how it goes. Right, so when you differentiate this, we have 2x. When we differentiate ln x, we have 1 over x divided by this whole thing. Okay, so divided by x plus ln x. All right, so always we are interested in the inner bracket. Okay, now you are done at this point. You are done with the calculus. What is left with is algebra. We need to clean this up. Okay, so we can say that 2x will multiply x, so that you have 2x squared. Then you know this is over 1. That will also multiply this, which is 1, and you divide by x. Okay, so that's what we have divided by this thing. Okay, then this will reciprocate and then will multiply. All right, so at the end of the day, this is what you have. Right, now we have y is equal to log x to the base 3, and our job is to differentiate this. Okay, now this is what you should do. You change the base. So take this to the log of, let the base become e. Okay, so if it is the base of e, then it means you are dealing with natural log, that's ln. So we will take ln x over ln 3. Okay, so that is what the third law of logarithm says. Okay, so when you change the base, it takes this divided by this one. Okay, so let's do that. So let's change the base. So as soon as we change the base, this is what we have. Ln x, okay, it takes the first one divided by ln 3. But ln 3 is a number, it is not a function, so we can pull that out. Okay, we can factor that out so that we have 1 over ln 3 times ln x. Now we have this function. So when we are differentiating, we are paying attention to this. So let's differentiate. Now when you differentiate this, you have 1 over x. Okay, and then you clean this up and you will get 1 over x ln 3. 1 over x ln 3. Now we have this e raised to the power y is equal to 4x squared minus 1. Now my friends, whenever you are to differentiate something of this nature, e raised to the power y, then you need to take the natural log of both sides. Okay, and the reason is that natural log e to the power anything, the answer is that thing. Okay, So we will take the natural log of both sides. And the answer from here is y. It's a rule that says the natural log of e to the power anything, the answer is that thing. Okay. All right. So we get y here. So we have y equals this. Remember, this we can differentiate it easily. Why? Because we will differentiate what is here and then we divide by 4x squared minus 1. So when we differentiate 4x squared minus 1, we have 8x. Then we will divide by 4x squared minus 1. All right? And then we are done.